We can't see it or touch it, but it rules everything. From the ticking of clocks to the birth and death of stars, time shapes reality as we know it. But how well do we really understand this fundamental force of the cosmos? Today we explore the science, the mystery, and the mind-bending truths about time, a journey that takes us from the subatomic realm to the expanding universe and into the very essence of our own existence. What exactly is time? You can't hold it in your hand, you can't see it, and you certainly can't turn back the clock, though many of us have tried. We use time to measure change, to mark the intervals of our lives, from seconds to minutes, hours, years, even eons recorded in the geological strata of our planet. But what is it, really? Physicists define time as a dimension, just like space. Think of it this way, you move through space, right? Well, you also move through time, but there's a catch, a cosmic rule, if you will. While we can move back and forth in space, we experience time as a one-way street, always moving forward. At least that's what we perceive. For centuries, the profound thinkers, the philosophers, and the scientists, they assumed time was a universal constant, ticking away at the same rate for everyone, everywhere. Then along came Einstein, a man who dared to question the very fabric of reality. His theory of relativity turned our understanding of time on its head. Einstein showed that time is not absolute, it's relative. Now, stay with me here. Time can actually slow down or speed up depending on how fast you're moving or how close you are to a massive object. That's right, time is flexible. We call this time dilation. It's not science fiction, my friends, it's real. Astronauts on the International Space Station, they actually age a tiny bit slower than us here on Earth. And those GPS satellites that help us navigate, they have to adjust their clocks because time moves differently for them up there in orbit. Here's something truly remarkable. Our brains, they don't experience time like a clock. It's not as simple as seconds ticking by at a steady rate. Our perception of time, the way we feel its passage, it's influenced by a whole host of factors, our emotions, our memories, even our attention span. Think about it. When you're bored, time seems to drag on forever. But when you're caught up in a moment of joy or excitement, time seems to fly by. And in moments of danger, well, time can feel like it slows down to a crawl. Children, those wide-eyed explorers of the world, they experience time differently than adults. Why? Because their minds are processing so much new information. That's why those long summer days of childhood seem to stretch on forever. Chapter 4. Now, let's talk about time travel, because who hasn't dreamt of venturing into the past or taking a peek into the future? The mind races with possibilities. Here's the thing, Einstein's equations, those elegant descriptions of the universe, they actually allow for time travel, but there's a catch, at least for now. We can only travel forward. Imagine this. You board a spacecraft that can travel at speeds approaching the speed of light. As you approach this incredible velocity, time slows down for you relative to those you left behind on Earth. You return home after what felt like a short trip, but years, decades, or even centuries could have passed back on Earth. Time travel to the future is not science fiction, it's a consequence of the laws of physics as we understand them. But traveling to the past, now that's a puzzle we haven't quite solved. Some physicists believe that wormholes, those theoretical tunnels through space-time or closed time-like curves, might hold the key. But for now, time travel to the past remains a tantalizing mystery. Chapter 5. Time and the Brain. Your brain is the most complex object in the known universe, a 3-pound universe unto itself, and it plays a fascinating trick with time. You see, your brain is constantly creating a sense of now. But now isn't a single isolated point in time. It's more like a short window, a span of about 3 seconds, where your brain processes and integrates sensory information to create your seamless perception of reality. Your brain, in a sense, is a time traveler, constantly stitching together the past, the present, and even anticipating the future to create a coherent experience of time. It's why time can feel so strange after we wake up, under anesthesia, or during those moments of intense focus when we lose track of time altogether. Chapter 6. The Arrow of Time and Entropy. We've talked about time travel, but here's the real cosmic puzzle. Why does time move forward at all? Why can't we reverse the arrow of time? The answer, it seems, lies in a concept called entropy. Entropy is the universe's tendency to move from order to disorder. Think about it this way: you can break an egg, scrambling it into a delicious mess, but you can't unscramble it. That's entropy in action. The universe, according to the second law of thermodynamics, is constantly moving towards a state of higher entropy, from the Big Bang to the eventual heat death of the universe. This increase in entropy, this cosmic unfolding, is what gives us the sense of time moving forward. Chapter 7. Mind-bending theories. We've explored the science of time, delved into Einstein's revolutionary ideas, and even contemplated time travel. But the quest to understand time takes us even deeper into the realm of the unknown. Some physicists, some of the most brilliant minds on our planet, believe that time as we perceive it might be an illusion. Others propose that all moments in time, the past, the present, the future, they exist simultaneously in a colossal block universe, a concept that stretches the mind to its limits. Quantum physics, that realm of the very small, suggests that time itself might not be continuous at all. Perhaps it's composed of tiny, discrete units like frames in a movie, constantly being projected onto the screen of our reality. And then there's the mind-boggling possibility that time emerges from deeper, timeless laws of the universe that we have yet to comprehend. Outrow time, it's everywhere and nowhere all at once. It's the silent conductor of the cosmic orchestra, orchestrating the dance of galaxies, the birth and death of stars, and the fleeting moments of our lives. It connects us to the vastness of the cosmos and to the intimacy of our memory. And while we may not be able to control time, we can certainly keep exploring its mysteries, unraveling its secrets, and marveling at its profound influence on our existence. If you've enjoyed this journey through time, don't forget to subscribe to Quick Facts and keep learning with us. The universe awaits, and there's still so much more to discover.